For this question, it says, a skull cleaning factory cleans animal skulls of deer, buffalo, and other types of animals using flesh-eating beetles. A factory owner started with only 6 adult beetles. After 50 days, the beetle population grew to 18 adult beetles. How long did it take before the beetle population was 6,000 beetles? So we're going to assume that this model is an exponential model. And using this information right here, that we started with 6 beetles, and after 50 days, that beetle population grew to 18 beetles, we're going to be able to find the growth rate. Okay, so what I'm talking about with an exponential model is that it will follow A equals A naught e to the kt. Let's start with A naught. A naught is the initial population. T is time. And K is either the growth or decay rate. In this example, we're starting with 6 beetles and it grows to 18 beetles, so this is a growth rate. And when we do our calculation, when we have growth, K will come out to be positive. If you ever have your population getting smaller, it will be called a decay rate, and K will be calculated to be negative. So with this information from the beginning about starting with 6 adult beetles and after 50 days the population grows to 18, we're going to be able to figure out what the growth rate is. And then once we know the growth rate, then we're going to be able to answer the question that's posed on the second part, which is how long did it take before the beetle population was 6,000 beetles? So let's start with finding the growth rate. So we start with our formula, A equals A naught e to the kt, and we know A naught is the initial or beginning population of 6. A is the ending population or the accrued amount, and that is going to be 18. And we also have a time of 50 days. So we substitute that time in. We have an exponential equation because our variable is in the exponent, and we're going to solve this equation using the methods of exponential equations. So we start by isolating the exponential part. So this part is the exponential part that has our variable, and we want to isolate it. So we're going to divide by 6 to get 3 equals e to the 50k. Then we'll continue to solve. We have different methods that we could use for solving exponentials. The basics are trying to make the bases the same, which we can't do in this example. We can convert it to a log or take the log of both sides. Either one of those methods you could use. I'm going to take the log of both sides. So I'm going to do natural log on the left and natural log on the right. On the right-hand side, I can use the power rule and move that exponent to become the coefficient. That becomes 50k, natural log of e. I can simplify this further because natural log of e is 1. So that becomes 50k times 1, which is just 50k. And then I can divide both sides by 50. So now I've found the growth rate to be natural log of 3 over 50. Now I don't want to use the approximated value, but I want to show you that when we type this in your calculator, natural log of 3 divided by 50, we get that positive value for the growth rate. I'll go ahead and I'll round it to 0.022. That's approximately 0.022, but you never want to round until the very end. And so I'm going to use this in my calculation rather than this value. All right, once I have the growth rate, then I'm going to be able to answer the second part of this question. How long did it take before the beetle population was 6,000 beetles? So we can take our formula again. A equals A naught e to the kt. Remember, we now know the growth rate to be natural log of 3 over 50. The question says how long, so that means that the thing that we're looking for in this problem is time. And so then we've got how long does it take for the beetle population to reach 6,000? So that is our value of A. That's going to be the 6,000. Our initial population, remember, is 6. 6 beetles to start with. So we have everything except for the variable we're trying to solve for. So I'm going to substitute 6,000 equals 6 e to the natural log of 3 over 50 t. This is once again an exponential equation. We're trying to solve for a variable that's in the exponent. We're going to solve by isolating the exponential. We're going to divide both sides by 6. That's 1,000 equals e to the natural log of 3 over 50 t. Once again, I'm going to take the natural log of both sides to solve the equation. Once again, I can use the power rule to bring that to the front. Natural log of 1,000 equals natural log of 3 over 50 t. Natural log of e. Natural log of e is 1. We have natural log of 1,000 equals natural log of 3 over 50 t. Natural log is 1, so that's why that went away. 1 times anything is itself. And then I'm going to divide both sides by 50. I'm sorry, not just 50, that whole coefficient. I'm dividing by natural log of 3 over 50. That cancels this coefficient out, leaving me with t. And here I'm dividing by a fraction. When we divide by fractions, we can multiply by the reciprocal. So that's 50 over natural log 3 times natural log of 1,000. And I'm going to type in my calculator 50 natural log of 1,000 over 3 to see what that time is. Yeah, 50 natural log of 1,000 divided by natural log of 3. We have 314 days It will take 314 days for our beetle population to grow to 6,000 beetles. Thank you for checking out my videos. Have a great day.